Lesson 4.3, Elastic and Inelastic Collisions. Kinetic energy is the energy of motion, which means it is energy things have just because of movement. And kinetic energy is 1/2 mv squared. At the subatomic level, kinetic energy is often conserved during collisions. But at the macroscopic, or the big level, the size of collisions we're used to, kinetic energy is usually not conserved. During the collision, some of that energy is converted to heat. Some is converted into distortion or damage. A collision where the kinetic energy is conserved is called an elastic collision. If the kinetic energy is not conserved, it's called an inelastic collision. And if the objects stick together, it is completely inelastic collision. Let's say you're playing marbles. Your 0.1 kilogram shooter is traveling at 1 meter per second and hits a stationary 0.05 kilogram cat's eye marble. For an elastic collision, what are the velocities after the collision? Well, since it's a collision, we can have conservation of momentum. So we can say mv plus mv equals mv plus mv. So this would be, let's use the shooter and the cat's eye. Shooter and the cat's eye. So the mass of the shooter at 0.1 meters, or 1.0 meters per second. The cat's eye, and it's initially stationary, so its initial velocity is 0. The shooter, and it has some final velocity. And then the cat's eye, and it has some final velocity, but they're not the same final velocity. So if I multiply these, I get 0.1 kilogram meters per second equals 0.1 kilograms VFS plus 0.05 kilogram VFC. I think I'm going to divide both sides by the 0.05 kilograms. And I'll end up then with 2 meters per second equals 2 kg VFS plus 1 VFC. So then, if I subtract, I can solve for the VFC. Why would I want to do that? Well, I have two variables, so I think I'm going to have a system of equations. All right, my other equation, see if I can squeeze it in here. Since it's elastic, kinetic energy is conserved, so that'd be 1/2 mv squared plus 1/2 mv squared equals 1/2 mv squared plus 1/2 mv squared. So my shooter and the cat's eye. Shooter and the cat's eye. All right, and the mass of the shooter and its initial velocity squared. The cat's eye is initially stationary, so I'm just going to put a 0 for it. Mass of the shooter times its final velocity squared. Mass of the cat's eye times its final velocity squared. So this gives me 0.5 meters squared per second squared equals 0.05. Sorry, that is 0.05. 0.05 kilograms VFS squared plus 0.025 kilograms VFC squared. So I think what I will do is I will divide everything by the 0.025 kilograms. If I do that, I'll end up with 2 meters squared per second squared equals 2 VFS squared plus VFC squared. So if I do substitution, I'll have 2 meters squared per second squared equals 2 VFS squared plus VFC squared. But VFC is that. So that is 2 meters per second minus 2 kilograms VFS squared. Now when I square it, it's times itself. You'll end up with 4 meters squared per second squared minus 8 kilogram meters per second VFS plus 4 kilogram squared VFS squared. All right, since this is quadratic in the velocities, let's move everything to the same side. All right, for the squareds, I've got 2 and 4 is 6. I'm going to drop the units for now, it'll be slightly easier. For the just VFS, I got minus 8. And then I'll need to move that over. That would be 2 meters squared per second squared, but it's dropping the units. I could factor out a 2. And I think I could continue factoring. I could make this 3 VFS and 1 VFS. To get the 1 be minus 1 and minus 1, which does add to be the negative 4 in the middle. So then I take each of those equal to 0, so I'll have 3 VFS minus 1 equals 0, or VFS minus 1 equals 0. So I'll have VFS equals 1/3, and that would be in meters per second, or VFS equals 1 meter per second. Now I have two options. The shooter was already traveling at 1 meter per second at the beginning. After it hits the other marbles, will it continue the same speed or not? Probably not. So the shooter is going at 1/3 a meter per second. Now that I know that, I can find the cat's eye, which is 2 minus 2 VFS so the cat's eye is 2 minus 2/3, or 1 and 1/3, 4/3 meters per second. Police will sometimes reconstruct car accidents. In one accident, the cars stuck together and slid 12 meters before they stopped. They measured the coefficient of friction as 0.70. The blue car's mass is 1,100 kilograms, was sitting at a stop sign when it was hit by a red car whose mass is 990 kilograms. How fast was the red car going when it was hit by the blue car? Well, we're going to work backwards. So after the accident, we're going to use forces and kinematics. So for the forces, here's our smashed up cars. We have weight, which is mg, normal force up, and friction backwards. So if I go into y with F equals ma, it's normal force up, weight down, and there's no acceleration in the y. So my normal force is mg. In the x, my only force is friction. There is acceleration. Friction is the mu times the normal force. My mu is 0.7. My normal force is mg. I can divide both sides by the m and plug in the 9.8 for the g. So my A is negative 6.86 meters per second squared. How does that help? Well, now if I do the kinematics, I know my A, I know my initial position is 0 and my final position is 12 meters. To do momentum for an accident, I need to know velocity. So I know the final velocity of them combined is 0 because I stop, and I'm looking for the initial velocity. So this would be the v squared equals v0 squared plus 2a d minus d0. Okay. So that gives me, if I subtract the v0 to the other side and multiply all that together, divide by a negative and take a square root, I get 12.83 meters per second for when they were right before the accident, or right after the accident, sorry. So then, during the collision, I use momentum. Now this becomes the final velocity for the crash, the collision. So the one car is 1,100 kilograms, and that blue car was sitting still, so its initial velocity was 0. The red car was 990 kilograms, and we're looking for its initial velocity. After the collision, they are moving at 12.83 meters per second. Both of them together, so they have the same velocity after the collision. Multiply all that together, and then divide, and V0 is 27.1 meters per second, which is how fast the red car was going.